then you'll have some time to get started on the review assignment. So again, this is number 10.
Okay, slide number 10, which was the square root of 125 plus the square root of 80, but those can't square root evenly, so you have to factor them to the square root of 25 to the square root of 5 plus the square root of 16 to the square root of 5, and the square root of 25 is 5, and then you can't factor the square root of 5 anymore, so it's just square root of 5, plus the square root of 16, which is 4, and then same thing, so it'd just be the square root of 5, and since they have the same square root, you can add the 5 plus the 4, which is 9, so then you have 9 and the square root of 5.
Any questions on number 10? So the square root of 80, picking the square root of 16, that's the largest perfect square. So you need to choose the largest one so that you can combine them together since they're now like terms. Please talk to you. Can you just put that in the black bin over there? And Garrett has number 20.
I had a 20, which was the square root of 125 x to the fourth and y to the fifth. There's no square root of 125, so I factored it to square root of 25 and square root of 5, which is 5 square root of 5. I divided out the x to the fourth, so I got x squared, and then I got, for y to the fifth, I used y to the fourth and y to the first to get y squared and then square root of y squared. Y squared? Yeah, and then, so my final answer was 5x squared, y squared, 5y.
Any questions for Garrett? So that was a square root one, taking the square root of each of those terms and simplifying. And then Will has number 23.
At number 23, it was the cube root of x squared times the cube root of x to the fourth to the power of negative 3. And the first thing I did was distribute. When you distribute, you get the cube root of x to negative 6 times the cube root of x to the negative 12. And since it's negative, you have to put it under 1. And when you do that, you get the cube root of x to the 6 times the cube root of x to the 12th. And you have to do 6 divided by 3 and get 2, and 12 divided by 3 and get 4. When you do that, you get x squared times x to the fourth, and since you're multiplying two exponents, you have to add them, so you do 4 plus 2 equals 6, so you get 1 over x to the sixth.
Any questions for Will? So if you look at the back of that page, looking at 17, 18, and 19, those three equations there. So when you're solving an equation involving something that's cubed, squared to the fourth to the fifth, the goal would be to isolate the exponent, but in number 17, if it's already isolated, how do you get rid of that quantity that's cubed? Julia, sorry. Say it again. Cube rooted, right. That exponent doesn't distribute through. So this exponent doesn't just bump through the parentheses because there's a plus sign there. So really that means that there are three of those quantities. So you could choose to multiply them all out, but that would be the really long way to solve it. Instead, we want to do the opposite. So if it's cubed, we want to take the cube root of it. And is there a cube root of 512, Julia?
Yeah, it's 8.
Yeah, it's 8. Do you put a plus or minus in front of that, Julia?
No, because you're dividing by one.
Yeah, and it's a cube root. So in number 17, you take the cube root of both sides. The cube root of 512 is just 8 because it's an odd root. It doesn't get a plus or minus with it. And then you would take the 2 to the other side. You get 6. You divide by 3, and you just get x equals 2. However, in number 18, you're going to take the 3 to the other side because you're isolating whatever's squared. You divide by 3. And then you take the square root, but this answer is not 10. Because a square root says 10 times 10 makes 100, but negative 10 times negative 10 also makes 100. So the difference between an odd root versus an even root. So any odd power, it's the number whatever is underneath. If it's positive, it's positive. It's negative, it's negative. But when it's an even power, a 2, a 4, a 6, an 8, then you have to have that plus or minus, because anytime you're multiplying an even value together, 2 negatives make a positive, 4 negatives make a positive, 6 negatives make a positive. So that's why that plus or minus is there. So anytime it's an even root, don't forget the plus or minus when you're solving the equation. Are there other questions on that worksheet? So we're just going to quickly go through then the couple of problems that are in the little warm-up that I passed out. So the first example is from section 4.5, and this is the radical problem where you're rationalizing the denominator. So we need to multiply this by something so that we get a radical out of the denominator. So anytime there's any type of radical in the denominator, we need to rationalize it in order to get that radical out. And the homework I handed back to you, please look over that because I made corrections on that yesterday as I was grading them, looking over them. So please make sure that you look over that homework that I handed back to you because I did make some notes on there. So how would you rationalize this denominator? Gotta multiply by something. Julia?
You multiply both the top and the bottom by 1 minus the square root.
Yeah. So we're going to multiply top and bottom because whatever you do to the one piece of the fraction, you have to do to the other piece. And you're multiplying it by the opposite. So there's a 1 plus 2. We're going to multiply it by its opposite of 1 minus 2. By doing that, that should help get that square root out of the denominator. So when there's more than one piece, more than one term in the denominator, you multiply it by its opposite. So multiplying this really means that in the top, you need to distribute negative 3. On the bottom, you're going to be foiling those two pieces together. So Julian, if you multiply negative 3 through on the top, that gives you?
Negative 3 plus 3 squared.
Good. So multiplying the 3 and the square root of 2, that 3 just goes in front of the square root of 2. And then on the bottom, you're foiling this. So you're taking the first terms, which would be 1, the outer term, 1 and negative square root of 2, the inner term, square root of 2 and 1. And then the last terms, we have a positive square root of 2 and a negative square root of 2. So the square roots cancel, and that just leaves us with the square root of 2. When you multiply the square root times the square root, you get the square root of 4, but the square root of 4 is 2. It's a negative 2 because the plus or minus sign in front. So our goal was to get rid of the square root in the denominator, and these middle terms, a negative square root and a positive square root, now cancel out. On the top, we have a negative 3 plus 3 square roots of 2. On the bottom, it's just a 1 minus 2, which gives us a negative 1. So Abby, your final answer would be
3 minus 3 squared 2.
yeah. So 3 minus 3 square roots of 2. If you want to place it over one, you can. Or you can just keep it as 3 minus 3 square roots of 2. When you're dividing by negative 1, you actually want to divide each piece by negative 1 and simplify it. Questions? So if you look at number 2, we have the quantity x plus 5 cubed, and that's equal to negative 32. So what would you do first to solve this problem? Phil, what do you think?
Cube root -32.
Yeah. So there's nothing that we want to do with that cube part besides take the cube root of both sides to get rid of it. So the cube root of the left and the cube root of the right. So right here we have the cube root of -32. Will, is there anything we can do with the cube root of -32 to break it down?
8 and 4. -8 and 4.
So he said -8 and 4. So we need a number from the perfect power sheet, that common power sheet. 8 times 4 makes 32. The reason we're choosing that 8 is because it's a perfect cube, so will the cube root of -8 becomes -2. And then we still have the cube root of 4. So over here, this is my little bit of scratch work to break down the -32. So you're cube rooting -32, that means we need to break that number down and try and simplify it. And then the last thing we need to do is get x by itself, so that means we're taking the 5 to the other side, so we have a -5. And then the radical is -2 cube root and then 4. Just be really careful that your cube root and your -2, like that cube root is part of the radical. The -2 is separate, so you're not multiplying those together. The cube part, the 3 part, is part of the root. Questions? The last group of problems here are just all the simplifying problems. Some of them involve variables, some of them don't. But pretty much just asked to simplify the expression. So if we can, we want to combine terms. If we have numerical values, we want to try and break them down using the power sheet. Maggie, what do you do when there's an exponent outside all of the values in the parentheses? Yeah, so you distribute it to everything. So it even gets distributed to the 2. So it's going to the 2 and becoming 2 cubed. Because every piece has an exponent, whether it's a number or a variable. And then we have the 3 with the 3 for the x, so that becomes 9. And then Maggie, do you know what the y power would be? What's y to the 2/3 and then cubed? If you multiply, so 6/3, so 6/3 just becomes 2, yeah. And then same thing on the bottom, so that 3 goes to every piece of the bottom. The x is 5/3 times 3, so that would be 15/3 or just 5. Y is 9, and then z would just be 3. So that's distributing. Distribute means multiply. Every single one of those exponents has a value that's multiplied by 3 as an exponent. So simplifying it a little bit here, Maggie, what is 2 cubed? 8. And then looking at the x's, what does that become? Good, x to the 4th. And then the y's, the larger y is on the bottom, so that y would become what, Maggie? Y to the 7, not 2. And then finally, the z cubed. So wherever the larger power is where your variable should remain. There is no z to combine with anything in the numerator. So 8x to the 4th, y to the 7th, z cubed. So Emma, number 4, we have the cube root of 27, the cube root of 128. What would you do for that? So this just becomes 3. How about the cube root of 128? And 64 is 4, yeah. So we have 3 times 4, and then the cube root of 2. So 12 cube root of 2. Maybe whenever it appears. So number 5, again similar to 3, but now we have two quantities with an addition sign. The only way we can add those together is if the exponents are exactly the same. So if you apply that same process that we did for number 3, distribute the exponent through. So Matt, if we have 8 times 110, what does that become? So 8 times 110 is 8 tenths. What is 8 tenths reduced to?
4/5.
There you go, 4/5. All right, Matt, how about the next one? 4 times 110, which is,
2/5.
there you go. So now we have x to the 4/5, y to the 2/5. There's a 3. That 3 is outside the parentheses, so it stays outside. It does not get affected by the 4. And then, Matt, what would be the exponent of the x and y in parentheses after you distribute?
X to the 4/5. Y to the
Yeah. Matt, what number is in front of the first x and y?
1.
A 1. So what can you do with these, Matt? Add them. You're adding the 1 and the 3. Because now the part that's behind it is exactly the same. So they're like terms. The power and the variable match up. So 1 plus 3 gives us 4. And then the variable with the exponent, those don't change. Because you're just adding the terms in front. Just like this said 1x plus 3x. So you're just adding the numbers in front. The variable remains the same. So it should be a 4 now. And then x to the 4/5 plus y, or times y to the 2/5. Any questions? So the last two expressions, we have one numerical, one with a combination of both. So 2 and then the square root of 9 to the 5th plus 7 square root of 9 to the 5th divided by the square root of 9 to the 7th. Odette, what do you think you would do first?
I would add the numerator and non-numerator.
Yeah, and so in the numerator, those are like terms. They're both the square root of 9 to the 5th, so we can add those numbers in front. So at least now the numerator is combined. What else, Odette? What else do you think?
I would rationalize the denominator.
Okay, so she said she would rationalize the denominator, so that would be one option we could do. What would another option be? So Odette, you're not wrong. That just might involve a couple extra steps. Julia?
Could you go back to like the exponents and then 9 to the 5th? 2 9 times 9 to the 5th, 2 9 times 9 to the 6th.
So, what does this become?
9 to the 5th. I mean 9 to the 5th.
There we go. 9 to the 5 over 2. And on the bottom, 9 to the 7 over 2. Odette, is that what you meant? Yes? Sorry. So we're going to flip them so that they're in fractional form. So right now it's as a radical. Flip it so that it looks like a fraction. So we have the 9 that's in front, and then changing the radical, the square root of 9 to the 5th is really 9 to the 5 halves, because the square root has a little 2 here. The square root of 9 to the 7th is really 9 to the 7 halves. Alright, so we still need to try and combine these together. We've got to simplify them. What else can you do? And it just kind of depends on what you see first. Got a lot of 9s up here, 3 of them. They all need to be combined together because they're all 9s. So somehow we have to combine them together. What could you do with the top part?
Multiply 9 and 9 up to the 5 halves to get 9 to the 7 halves.
So this 9 has an exponent of what?
1, which would be 2 over
Right, this 9 has an exponent of 1. So really this is 9 to the first. And because you're multiplying, we would add those together. So that becomes 9 to the 7 halves. So the 9 that we created by adding 2 plus 7 together really has an exponent of 1. Well, an exponent of 1 is really 2 over 2, so that we have common denominators. When you're multiplying and the base is the same, you add the exponents together. So we have 9 to the 7 halves divided by 9 to the 7 halves. What's 9 to the 7 halves divided by 9 to the 7 halves equal to? Not a trick question. 1, yeah. So you can look at that 2 different ways. The same thing divided by the same thing is 1. Or when you have exponents, you're supposed to subtract. Well, 7 halves minus 7 halves is 0. 9 to the 0 is also 1. So either way, you can kind of validate why it's equal to 1. But if you have the same thing divided by the same thing, it's always equal to 1. All right, so the last one up here. We have 6 and then the square root of x squared times the square root of x squared divided by 81 and then the square root of x to the 16th. Kenzie Myers, what do you think?
What I did first was the square root of x squared. So you got x from both of them. So I multiplied those to get 6x squared. And then I took the square root of x to the 16th, which is x to the 8th.
Good. So on the bottom, the square root of x to the 16th. Remember, you're really dividing there. So a square root has a 2. So you're taking 16 divided by 2, and that gives us x to the 8. So the square root of x squared is just x. So there's 2 of them, which is how we get x squared on the top. The square root of x to the 16th is really x to the 8th. And then what else could we do there, Mackenzie?
You could divide. So you, they 6 and 81 share a common factor of 3, so you get 2 and 27, and then you subtract the exponent to the x, so you get x to the 6th on the bottom.
Nice job. Good explanation, too. So 6 and 81 have a 3 in common. They're both divisible by 3. And then the x's, you're subtracting them. Wherever the larger power is, would be where your x remains. So when you subtract those powers, x to the 6th is in the denominator. So if you take them piece by piece, do a little part at a time so that you're less likely to make a mistake or an error. So you have the next, it's 15 minutes. We go to 8:18. There are many Algebra 2 books on the side of the classroom. Make sure it says Algebra 2 and not my pre-Algebra 2 books, and make sure it does say Algebra 2 on it. Graduate partner, the homework is on the board back there. I'm going to send out right now the solutions. So it's page 1013 and 1015. And I'll send out the solutions so that you have those.